Hello and welcome to Smart Talk, Data and Motion Leadership Series. This is a brand new episode with Luke Roquet, our guest who is the Chief Operating Officer at Datavolo. Luke is no stranger to the data world. He has been in senior operations and sales leadership roles at a variety of data management companies like Cloudera, Hortonworks, Unravel Data, AWS, and so forth. So we are excited to have you here, Luke. Welcome.
Thanks, Dinesh. Really excited to be here.
Yeah. So before we start, why don't we give you an opportunity to quickly explain who Datavolo is, what you do. Why don't you take the floor?
Yeah, it's pretty simple. Our mission is to help folks become 10x data engineers for AI. AI presents a whole new set of challenges and opportunities with regards to how to manage the data pipelines. And fundamentally, when we talk to companies doing AI, we find that data engineering is a major bottleneck for generative AI use cases. So our mission is to help people easily harness all their multimodal data for their AI applications.
Fantastic. And I think that's exactly why we invited you to the show today, because we've been talking about data in motion and the context of data in motion in today's world, particularly when it comes to Gen AI and all that. And I think it absolutely makes sense to focus specifically on data pipelines as a topic for today in the context of Gen AI. And I think that makes more sense because it all starts there, is how I would like to say. We have talked about data in motion last episode. We spoke about how in the context of Gen AI it is applicable, and how we need to not just look at one side of data alone, and data in motion also plays a very relevant role and all that. But what we didn't get into was like a double click into that about like the architecture of it and all that stuff. Uh, in your vantage point, particularly as you start embarking on this journey with Datavolo, how do you see the current data architectures? Do you see gaps in how they are addressing the Gen AI applications of today? And what are some of these gaps that you see that should be addressed?
Yeah, it's very interesting because, like you, Dinesh, have been in this data space for a very long time. And back in the early days of Hortonworks, let's call it 2012, 2013, when I first started there was all this promise about big data letting you harness all of your structured data, your semi-structured data, your unstructured data. But the reality is, if you look at the market today, the vast majority of workloads in big data environments are highly structured data. And so as a result, the data architectures have evolved to suit that type of world. So the leading data pipeline tools of today are built around row-oriented constructs, around highly structured context of how they process data. They've even changed from an ETL to an ELT type construct because that's what the demands of the enterprise have been for the last decade. But the reality is, with generative AI now, these models can really truly harness this unstructured data for the first time. So the 90% of data that companies have, the enterprises have, that previously they've never been able to tap, they can now tap with generative AI, which opens up a tremendous amount of possibility, but also opens up a tremendous challenge in terms of how do we manage the fundamental data that enables these AI applications. And if you read anything on the internet about why generative AI has been a little bit slower than we expected it to be in the enterprise, the number one reason is because of the data, because companies don't have the systems in place to handle the data to make the AI successful, and your AI is only as good as your data.
There you go. I think you nailed it with that last punchline there. Data has always been the most relevant thing in pretty much any setup that you have. And particularly in this context, I think you're right. Data is where it all starts. So with that said, and particularly since you kind of started talking about ETL, ELT and all that, I want to kind of highlight that. I think you and I have been kind of had the same pedigree when it comes to like data management companies. And we've been through this evolution of data pipelines, as I like to call it, where a couple of decades ago we were like talking about like ETL type pipelines where we would like get data from different types of sources, do all kinds of transformations and then load it somewhere else and so forth. And then came about this whole movement with like big data and like the data warehouses of the world and all that. And people started thinking ELT is a much better way, where we can like load it up and then like do whatever transformations we want and all that. Do you see a change even in that when it comes to the current needs of Gen AI applications, particularly as we start building like LLMs left, right, and center? How are these changing? When it comes to like data pipeline, what is the model currently that is
Yeah,
more
I
favorable?
think I think absolutely it demands a different construct, and that's because the T of transformation is fundamentally different for structured data and unstructured data. So in a structured data world, the transformation that's happening is by and large advanced complex joins, it's windowing, it's aggregation. So you want to get all the data in one place, a large data lake per se, or lake house, so that you can do advanced transformations and put it in a form which is then more semantically accessible by your SQL engine. That's the world of the enterprise has been living in today. And that's why all of the leading data pipeline tools today, and you know who they are all ELT based, right? But then what happens now with the notion of AI, generative AI, is that we need to fundamentally transform the unstructured data to a numerical representation that can be understood by a model. And to do that doesn't require complex aggregations and joins. And it truly is a simple transformation of an unstructured file or document or stream to a numerical vectorized representation of that into a vector store. And so as a result, what happens is you see kind of kludgy architectures being proposed all over the place. Things like ELTL or ELTP, where essentially because we have these point-to-point notions of data movement before you can transform it, you have to move the data to the lakehouse, then you do the vectorization, then you have to pick it up and you have to move it again. And it just simply doesn't make sense in a unstructured multimodal world. So the reality is that the proper way to do pipelines on this multimodal data is to do that transformation on the fly and put the data where it needs to go. So I'll give you an example, a very simple example. You're bringing in a large set of PDF documents. You need to vectorize, you need to parse them, you need to chunk them, you need to vectorize them, put them in a vector database, and then also store that original document in probably your lakehouse for reference. But you've done that all in one flow that then can be easily updated. And look, this world is evolving rapidly. The embeddings engines keep changing, right? The best parsers change, the best chunking strategies change. And so you need an ETL tool that lets you handle and orchestrate that process in a way that's very modular and very adaptable.
Fantastic. And from my vantage point, what I also see is as you start laying out this architecture of like this vector database and the embeddings and the chunkings and everything that happened between that and the actual LLM, what I also notice is decision making is a lot more complex. You know, it is like just not with this kind of a data that is coming in from all the structured data. Suddenly, there is also data streams that are happening that had to be added in for context and correlation in order to make those key decisions and all that. So what I'm also seeing is that there is a tremendous amount of like decision-making engines or platforms that are on the rise that need data from all these different pockets and that need to kind of bring it all together, where they can put it together and make the LLM kind of speak the truth in a way. Yes. Which brings us to probably a question that I have to ask you. Let's talk about the pink elephant in the room, hallucinations, right? So every time we bring up like GenAI applications or LLMs these days, people always worry about like a few things. 54%, I think is the number, or the number of companies, or the percentage of companies, I'm sorry, that are hesitant to put, GenAI to work, primarily because of the fear of either security or like hallucinations, the data quality and things like that. So where does it start, in your opinion, when you think of a multimodal pipeline that you put together of building this GenAI application? When do you start controlling data quality before it gets into the LLM's hands, before the LLM starts spewing out, whatever it thinks is the fact, but not confusing or misleading the user? Like, how do we prevent these kinds of hallucinations from happening, in your opinion?
Yeah, it's a great question. I mean, fundamentally, it should be noted that LLMs are built to hallucinate, right? That's what makes them novel and unique, is that they are built and designed in such a way that they can create new novel things that we've never considered, right? So they're built to hallucinate, but we want them to hallucinate in a factual way. And the way that you could do that is there's really kind of two primary ways, both completely centric around the data. One is you could spend a significant amount of time and money fine-tuning your own model with all of your own data, and heavily tune that model to set the temperature is a setting on a model to very low so that it doesn't hallucinate anything that it can't like just factually state. But then you lose some of the creativity and the power of the model by doing so. And then certainly you have the costs and such of doing the fine-tuning models. The approach that most organizations are taking is a RAG-based approach, a retrieval augmented generation approach, whereby you use a pre-trained, pre-tuned model, but then you augment it with the contextual data from your organization. And so then it becomes paramount that you are transforming the data in the right way, using the right parsers, the right chunking strategies, putting the right data in the vector database for the model to augment its model so that it's not hallucinating with falsities, that it's hallucinating or generating novel content based solely on the facts at hand of your organization and your business. So it really goes back to that point we made earlier again, that you can only trust your AI if you can trust your data, and your AI is only as good as your data. And at Datavolo, we primarily are working with large, heavily regulated enterprises that are very concerned about the risks that you talked about. And that is the major thing holding back generative AI in the market right now, is the unknowns in terms of how models are trained, in terms of hallucination, in terms of the risks of data privacy and security. Those are fundamentally the risks, and those are the risks that can only be solved by having a solid data architecture and a really solid data pipeline strategy to make sure that all of your data, because look, it's hard to secure this type of data that's in documents and video files and audio files and imagery.
Yep.
So having the right pipeline in place to handle that data so that you have the governance, you have the end-to-end lineage, you have that audit trail, that's fundamental to being able to do secure and trusted AI.
Uh, Phenomenal. I think that's a very comprehensive response to what I asked, which also raises like a whole bunch of questions. Starting with, what are some of the use cases that you typically see? Like maybe take your own company as an example with the kind of customers that you work with and all that. What are some of the use cases that you typically see, but that people are building with? Because that's another question that keeps rising in the field about I know Gen AI is on the rise. Everybody wants to like do cool and exciting things and all that, but are the cool and exciting things more practical? Are they being put to like real practical use cases? Is the question. One of the most common things that I keep hearing is customer success. Hey, I have a customer success application that I want to build. Gen AI is like an absolute wonder, because it can like take in tremendous amount of like documentation that I have, all my previous customer case studies, this, that, troubleshooting everything, and then sum it up and make like really clever responses to my customers for their problems. And I can implement chatbots and whatnot. And the possibilities are endless when it comes to like something like customer success. But what other use cases are you hearing about that make this field more lucrative?
Yeah, I mean, I think most organizations are starting with really low risk use cases, and you nailed one, which is a customer support, customer success chatbot. In fact, we have one that's part of our open community forums. People can come and ask questions. It sources both our documentation, but also it sources all of our chat history. We have an open public chat forum, I'm sorry, Slack forum, where experts are weighing in, answering questions. So when a new question is asked of the chatbot, it has not only the documentation that's kind of a point in time record, but it also is augmented by all the conversations that are happening by experts in our Slack channels. So that's a very common use case. Certainly, document summarization is a very, very common use case. Organizations want to load in all of their manuals, all of their documents, and be able to ask questions about this. Very common for legal documents. Any organization that has a lot of large PDF bases is a very common one. And then another really common one is actually around help desk calls, right? So you wanting to understand the tone, the sentiment of the folks calling into your help desk, and then understand, are your customer support folks handling those calls appropriately and giving the right answers and keeping the customers happy? Those are all examples of very low risk use cases to organizations where people are starting. The other place they're starting is, a lot of organizations say they're doing generative AI, and when you dig into it, they're really using ISV products, independent software products that use generative AI, right? So I think that's where we're at today in the enterprise, is that we're in the stage where we're doing very low risk, test the waters of what's possible, combine that with solutions from third parties that have built-in AI capabilities. And then where we're heading, though, is leaps and bounds beyond that, right? It's a complete and fundamental disruption of how analytics is done, around how forecasting is done, around what business innovation and capabilities are possible. That's what's coming. But we're still in the groundwork phase right now, where everybody's getting the foundational architectures laid down, testing and implementing low risk use cases, still high value, but low risk, and then laying that foundation for really the transformational disruption, which is a little bit down the road.
Awesome. Um, I want to also ask you, based on your last two responses, about the technology side of things, right? You and I come from the open source world, and we are very familiar with it. How do you see the current state of affairs when it comes to LLMs and all the stuff, and the openness that may or may not exist here? Do you see that as a challenge, or more as a support vehicle for you to get it more into the hands of customers to build more GenAI applications? So how do you see it? What do
Yeah,
you see?
it's such an interesting question, and one of frankly great debate across my network internally at Datavolo with customers, with thought leaders, and that debate is around, can the open source models catch up or keep up with these companies that have billions of dollars of funding, right? Like if you look at companies like OpenAI, Anthropic, et cetera, they have tons of money and resources, but shockingly, and no surprise to you or me, Dinesh, because we've been in this world for a long time, the open community is doing an incredible job at staying pretty dang close. And so what I'm seeing now in the enterprises is the enterprises, they're certainly experimenting with a lot of the public models, but at the same time, especially in fin services, which we do a lot of work in, there's a reticence to put your data out and accessible by those open models, and they want open source models that they can use within their own environs and their own constraints. And so if the open source models are almost as good, but it's fully known how they're trained, the training set, and it's controlled and owned in their model, that becomes very, very compelling to highly sensitive to security organizations. So I think it's a very interesting world. I think that the amount of money invested in some of these proprietary vendors like OpenAI will cause them to continually be ahead of the curve. But I think you're going to see open source continue to push the boundaries and stay right on the heels of the proprietary solutions.
Very cool. Very cool. No, I'm very excited about the promise of, what this stage is set, and how it is going to evolve in the next phase. I think it's going to bring in more innovations, competitions, and co-opetitions and whatnot. I think it's really exciting time
Yeah,
to
I
be.
mean, even if you look at it, we just think a little bit more big picture visionary, like the world that we're talking about, it's so exciting today and it's going to continue to get more exciting. Like one of the big challenges today that we deal with every day with customers is what's the right parsing strategy? What's the right chunking strategy? And right now we use different libraries from different vendors for those. And we might use one vendor today, and then next week Google might come out with something and we want to switch to that. But at some point, we're going to have a model that we can just say, here's my source data, and here's what I want to do with it. Go figure out the right parsing strategy, the right chunking strategy, and we just hand it off, right? So you're going to continue to see massive evolutions there. You're going to continue to see massive evolutions. You and I talked about this the other day, Dinesh, that the way that analytics looks today will fundamentally be different in 5 years.
Mm-hmm.
Like right now, we spend tremendous amounts of time and money getting data through multiple zones, bronze, silver, gold, platinum production, so that it's in this most refined state so SQL analysts can access that data. I don't believe that'll be the case 5 years from now. There will be certainly data sets like that. But the end state 5 years from now is that all of our data is coming in raw. It's being fed into a model, and then we just speak our own natural language to that model. And that's any language, right? Like we have at Datavolo, we have a flow builder where someone can go in English and they can say, hey, build me a flow that does this, and it builds them the flow. Somebody came recently and asked in Turkish, somebody from Turkey came, asked in Turkish to build a flow. And we were quite curious to see what would happen at Datavolo. We saw the
Uh-huh.
request come in, and what do you know? 60 seconds later, a flow was generated. So these models are so good at understanding people's natural language, and that's the evolution. We won't need to have all of these highly semantically structured data sets with highly semantically skilled people to access that data. We will be able to ingest data as it comes and be able to speak and interact with it in our own language.
Fantastic. No, that was great. And that was going to be kind of like my summary question of asking you about what you thought about the space. And I think you greatly touched on a variety of different topics. So thank you so much for that. And you mentioned flow. I just want to clarify it for the audience here. I know what a flow is. I've worked on it, but just for clarity, would you would call a flow a pipeline, or how are you
Yeah,
calling?
I mean it's different terms for the same thing. We often use those terms interchangeably, but yeah, the flow, the pipeline, it's really the orchestration of data from where it's originated to where it needs to go. And that's one of our fundamental theses and beliefs at Datavolo is that whatever advance has ever happened, and there will continue to be more and more advances, right? Today it's generative AI, next it'll be interactive AI or some other form. It'll continue to evolve. But what will always be a constant is the data and the need to get the data from where it originates to where it is consumed. And fundamentally, we believe those will always be two different places. So the orchestration and governance of how that happens, the chain of custody, the lineage to make sure that it's securely it's transmitted from point of origin to point of consumption is a fundamental thing that we will always be solving for.
Fantastic. Well, Luke, thank you so much for your time. I think I had a great conversation about understanding about Datavolo as well as the space that you're in, and the possibilities that are happening in this world of Gen AI right now. So appreciate your time and thank you for joining us.
Thanks, Nash. Really appreciate it. It was great to speak with you.
Yeah.